So this talk is faster than the speed of light nonsense. The people who believe in Einstein's relativity start playing games with the difference between special relativity and general relativity, and one of their favourite games is to say nothing can go faster than the speed of light, and next moment talk about things that can go faster than light, and do so by the blurring over special and general relativity. The example I have is Lawrence Krauss, and he's at that address there, and he's going to talk about expansion in the universe as faster than light. And I'm going to contrast that with Sean Carroll, who at that address is going to say something different. But as far as I'm concerned, they are just building on maths mistakes to enable them to say this nonsense. And let's see my example of these type of people messing up their maths at that address there. So it's continuation. They're building on maths mistakes and then talking nonsense. So we're going to go now to Lawrence Krauss. He's going to explain things. So as this person here is going to ask Lawrence Krauss to explain about the origin of the universe and so forth, and Lawrence Krauss is going to go into details about that, and what I'm concentrating on is Lawrence Krauss saying about the universe going to expand faster than the speed of light, and that's what I'm emphasising. Lawrence Krauss is saying a lot of other things as well, but I'm just concentrating on that one particular bit where he's going to say that, and that's the bit I'm emphasising. I could sort of attack all the other things he's saying, but it's sort of like you're overwhelmed by the sort of things these physicists say, and so you've got to pick each thing individually, and the purpose of this talk, I'm just going to pick on that little bit where he says that the expansion is faster than the speed of light. So he's got all the other things around it, and it's that bit which I'm criticising.
Less than 5 minutes, since this is a show that's time sensitive here. I would like for you to answer these questions. Where did the universe come from? What was there before it? What will the future bring? And finally, why is there something rather than nothing? Can you answer all of those things in 5 minutes?
5 minutes? Well, if I could answer them adequately in 5 minutes, I wouldn't have had to write a book about it. But where did the universe come from? From nothing. It seems to me. The answer is, of course, I don't know. But it didn't have to come from anything. It just could have appeared the same way lots of things appear in physics and don't violate any laws of nature. The entire universe could have, including space and time, could have been, and quite likely, based on what we can measure today, could have resulted from a quantum fluctuation, so that none of that current space in which we live and the time in which we measure things could have existed, and it could have all spontaneously appeared. And not only that, all of the galaxies and stars and matter and everything we see in the universe also could have spontaneously appeared without violating any laws of physics. So the answer is, it could have come from nothing, but who knows? And who knows, and if you're asking, was there anything before, which is the second question, there's two answers. The first answer is, it's not a good question. It may not be a good question, because if time and space both came into existence when our universe came into existence, and since space and time are tied together, then before doesn't mean anything. There was no before. All of these classical notions of causality, on which, frankly, a lot of religious tradition is based, first cause, prime mover, etc., they all go out the window if you give up the notion of before. There may not have been any before. Time itself may arise out of the creation of our universe, and therefore it may not make sense to ask what was before. On the other hand, there may be some global time quantity which one could describe usefully, and then it could be that our universe, in that case, you might say there's some global slice in what we would now call a multiverse, in which universes are being created and destroyed all the time, that may be eternal and timeless. And in that case, what may have existed, quote unquote, before our universe is a multiverse without our universe in it. And then our universe appeared. So that could be the case. As far as the future, it looks like it's likely to be dismal, but as I like to say, that's only in the sense of Charles Dickens in A Christmas Story, talking about the future as it might be. Happily, you might argue, we cannot prove what the future of the universe will be. We can only argue on the basis of what we see now and some current incomplete understanding about all the laws of physics. But based on everything we see now, the most likely possibility is that everything we see in the universe outside of our own galaxy and our cluster of galaxies will disappear. It will recede. It's moved away from us faster than the speed of light. And we will...
So did you get that? It's faster than the speed of light. So that's the bit I'm emphasising. He's talking about something that can go faster than the speed of light. And sometimes you get these people who believe in Einstein's relativity, and they start telling you nothing can go faster than the speed of light. So he suddenly slips it in among all the other stuff, faster than the speed of light. So I could have started criticising all the other stuff, but you've got all this stuck in the middle, all this other stuff which, well, what's the point of going into it? It's all built upon this idea about messing around with what you're saying about light speed and so forth. So he's saying faster than the speed of light for that bit. So if I pick it up again and then carry on to the end.
Could be the case. As far as the future, it looks like it's likely to be dismal, but as I like to say, that's only in the sense of Charles Dickens in A Christmas Story, talking about the future as it might be. Happily, you might argue, we cannot prove what the future of the universe will be. We can only argue on the basis of what we see now and some current incomplete understanding about all the laws of physics. But based on everything we see now, the most likely possibility is that everything we see in the universe outside of our own galaxy and our cluster of galaxies will disappear. It will recede. It's moved away from us faster than the speed of light. And we will ultimately, not we, but our galaxy will be long gone. Our galaxy will exist in an empty, dark, what seemingly eternal space. The stars will burn out, and the universe will become cold, dark, and empty. And as my late friend Christopher Hitchens would say, that's the simplest answer to the question, why is there something rather than nothing, is just wait, there won't be for long.
Right.
And finally, why is there something rather than nothing? Because there can be. And,
Okay.
And the laws of physics allow it, in fact, in some sense require it to be. So the really interesting question would be, why is there nothing rather than something? But if that were the case, we wouldn't be here to have this discussion.
That's true. You don't sound like a young Earth.
So that was what he was saying, and the bit I'm criticising, of course, I'm saying now is the speed of light bit. So if we go to now Sean Carroll, this is his website here, we have a look about him, about Sean. Sean Carroll, he's a physicist at Caltech, and I think I didn't have to introduce Lawrence Krauss because he's quite famous as a physicist, but this is Sean Carroll, and so we're going to go see what he has to say. And if we can make it bigger, right, not so good, right. So according to this, the universe never expands faster than the speed of light, and this is posted by Sean Carroll on the 13th of October 2015. So contrast that to what Lawrence Krauss was saying, the universe is going to go faster than the speed of light. So if we go to what he says here, he's breaking my radio silence here to get a little nitpick off my chest. The claim that during inflation the universe expanded faster than the speed of light is extraordinarily common, if utterly and hopelessly incorrect. I just noticed it in this otherwise generally excellent post by Fraser Cain, so he's referring to something else. A Google search for inflation superluminal expansion reveals over 100,000 hits, although happily a few of the first ones are brave attempts to squelch the misconception. I can recommend this nice article by Tamara Davis and Charlie Lineweaver, which tries to address this and several other cosmological misconceptions. So what Sean Carroll is saying, talking about fast and speed of light, is a misconception, and he's talking about it in the context of the beginning of the universe when there's supposed to be inflation, and some people say it's fast and speed of light, and he's saying that's a misconception. And in the other context, Lawrence Krauss was talking about the universe expanding later on, fast and speed of light. But you've got overall this idea of an expansion universe fast and speed of light as being a misconception. Right, this isn't, by the way, one of those misconceptions that rattles around the popular explanation sphere. It means people who are into science, but only as they find it as a sort of hobby. What experts sit back silently and roll their eyes. Experts get this wrong all the time. This one wrong all the time. Inflation was a period of superluminal expansion is repeated by the experts most of the time, lots of the time. For example, in the text by Tai-Pen Chang, by Joel Primack, and by Lawrence Krauss. So he's criticising even Lawrence Krauss, all of whom should certainly know better. The great things about the superluminal expansion misconception is that it's actually a mangle of several different problems which sadly don't cancel out to give you the right answer. And so he's going to go now into three little things to say about it. The first one is the expansion of the universe doesn't have a speed. Really, the discussion should begin and end right there. Comparing the expansion of the universe to the speed of light is like comparing the height of a building to your weight. You're not doing good scientific explanation. You've had too much to drink and should go home. The expansion of the universe is quantified by the Hubble constant, which is typically quoted in crazy units of kilometers per second per megaparsec. That's distance divided by time divided by distance, or simply 1 over time. Speed, meanwhile, is measured in distance over time, not the same units. Comparing the two concepts is crazy. Admittedly, you can construct a quantity with units of velocity from the Hubble constant. Using Hubble's law, v equals hd, the apparent velocity of a galaxy is given by the Hubble constant times its distance. Individual galaxies are indeed associated recession velocities, but different galaxies manifestly have different velocities. The idea of even talking about the expansion velocity of the universe is bizarre and never should have been entertained in the first place. So suddenly they're trying to say, via the first one here, number one, they're trying to disown the idea of the expansion of the universe as being a velocity or as a speed. Are just bluffing, basically. They've just got into the muddled nonsense. Point two, there is no well-defined notion of the velocity of distant objects in general relativity. That's pretty bad for poor general relativity then. There is a rule valid both in special relativity and general relativity that says two objects cannot pass by each other with relative velocities faster than the speed of light. In special relativity, where space-time is a fixed flat Minkowski geometry, we can pick a global reference frame and extend that rule to distant objects. In general relativity, we just can't. There is simply no such thing as the velocity between two objects that are located in the same place. If you try to measure such a velocity, you would have to parallel transport the motion of one object to the location of the other one, and your answer would completely depend on the path that you took to do that. So there can't be any rule that says that velocity can't be greater than the speed of light. Period, full stop, end of story. Except it's not quite the end of the story, since under certain special circumstances it's possible to define quantities that are kind of sort of like a velocity between distant objects. Cosmology, where we model the universe as having a preferred reference frame defined by the matter filling space, is one such circumstance. When galaxies are not too far away, we can measure their cosmological redshifts, pretend that it's a Doppler shift, and work backwards to define the apparent velocity. Good for you cosmologists, but that number you defined shouldn't be confused with actual relative velocity between two objects passing by each other. In particular, there's no reason whatsoever that this apparent velocity can't be greater than the speed of light. Sometimes this idea is mangled into something like the rule against superluminal velocities doesn't refer to the expansion of space. A good try, certainly well intentioned, but the problem is deeper than that. The rule against superluminal velocities only refers to relative velocities between two objects passing right by each other. So if you can follow all that, it's just muddling around words. Number one, they're just playing around with words a lot here. Playing around, 1 minute you can and next minute you can't, and just doing the same again here. They're just playing around with words. So next, on to the third point. There is nothing special about the expansion rate during inflation. If you want to stubbornly insist on treating the cosmological apparent velocity as a real velocity, just so you can then go and confuse people by saying that sometimes that velocity can be greater than the speed of light, I can't stop you. So there we go, another play on words here. So suddenly, wow, if after all these other points above here, 1 and 2, you still decide to carry on talking about what's he talking about, it's cosmological apparent velocity, and you treat it as a real velocity, well then you can talk about speed greater than light. Right, and it carries on here, but it can be and is greater than the speed of light at any time in the history of the universe, not just during inflation. There are galaxies sufficiently distant that their apparent recession velocities today are greater than the speed of light. To give people the impression that special about inflation is that the universe expanding faster than light is a crime against comprehension and good taste. So he's admitting here it's a crime here, basically. All this playing around with words, it's now saying it's going to be a crime. What's special about inflation is that the universe is accelerating during inflation as well as today, since dark energy has taken over. That's another bodge. After all the other playing around with words, we've got another bodge here, dark energy. The scale factor, which characterises the relative distance between co-moving points in space, is increasing faster and faster rather than increasing, but at a gradually diminishing rate. As a result, if you looked at one particular galaxy over time, its apparent recession velocity would be increasing. That's a big deal, with all sorts of interesting and important cosmological applications, and it's not that hard to explain. But it's not the superluminal expansion. If you're sitting at a stoplight in your Tesla, that's a car, Tesla car, kick it into insane mode and accelerate to 60 miles per hour in 3.5 seconds, you won't get a ticket for speeding as long as the speed limit itself is 60 miles per hour or greater. You can still get a ticket. There's still a thing as a reckless driving after all, but if you're hauled before the traffic judge on account of speeding, you should be able to get off scot-free. So they're just playing around with words again still. So basically it's summing up the conclusion here. Many misconceptions in physics stem from an honest attempt to explain technical concepts in natural language, and I try to be very forgiving about those. So now it's sort of like, after all this playing around with words, he wants to be forgiving for it. This one, I believe, isn't like that. It's just wrongly wrong. So he isn't forgiving after all. He doesn't. Well, after all this playing around words, he doesn't want to be forgiving. The only good quality of the phrase "inflation is a period of supernumerical expansion" is that it's short. It conveys the illusion of understanding, but that can be just as bad as straightforward misunderstanding. Every time it is repeated, people's apprehension of how the universe works gets a little bit worse. We should be able to do better. So what looks like, well, he's going to dismiss all this nonsense up here above as merely being the problem of putting it into natural language, all this nonsense here, point 1, point 2 and point 3, and he's trying to dismiss it as being a problem of putting it into natural language. And next minute, no, he doesn't think that's sufficient, and it's just wrong. The only good quality of the phrase "inflation is a period of superluminal expansion" is that it's short. It's just nonsense. It's basically all nonsense. He's coming up with these 1, 2, 3 points, playing around words, talking nonsense. So it's not fully Lawrence Krauss's fault. It's they're all wanting to mess around with words. And if we go back to here, this is my talk on it. This is what I point out in a lecture given on Einstein's relativity. This person is giving a talk on the maths, and what they do with the maths is they just make a big mess of it. And I point out where they're making a big mess of it. And so they just build upon that, and then building upon that, then they can talk their nonsense. One moment you can't go faster than the speed of light, next moment you can go faster than the speed of light, the next minute they're playing around with the words and it means something completely different. They're just all bluff, it's all nonsense. The end. Thank you.